Hello, my name is Doliner, and today I'll be presenting the circuits for the counters experiment. Now we proceed with 7.1. So part 7.1 includes two JK flip-flops connected like this, and we're gonna just go over all of the connections. So first of all, we have power connected to, this will be all of our JK power, and then we have another well, this actually is set and clear, then power, then J input, and then we also have set and clear here at the back. Now let's go over the powers here on the top. So we have K on the first one, then on pin 12 we have the other K for the second flip-flop by this orange cable, and then we have another power connected to J of the second flip-flop. So over here we have our input clock signal, which in this case right now is our logic switch. Then the output of this is passed to this LED because this is the first flip-flop. This is our least significant bit. We're represented here by our LED 4. And then we proceed. We connect it to the clock input of the next JK flip-flop on this IC. And then the output of it is being passed to the second bit on LED 5. The output is also being passed to that next JK flip-flop. Now, the power and grounds are connected exactly the same as this one on this other IC. The only difference being that instead of having their input for this clock signal to be a switch, like in this case, it's just being the output of the second JK flip-flop. And as I said, everything else is connected exactly the same. So we have the K1 then connected as an input to the next one, and so on. Then the output of everything is being, well, one of the outputs is this red cable going over here to LED 6, and that last one here on blue is being passed to the LED 7 on the most significant bit. So now let's test it out and see if it counts. So we see the 1, 2 in binary, 3, and so on. So 5, 6, 7, then we get an 8, 9, 10, 11, 12, 13, 14, and 15. And that's it for the first circuit. Now we proceed with figure 7.2, where we have our modified counter. So on the left, we have pretty much what we had before, except that our clear inputs are now connected to one single hop. So I just connected this clear from the first JK flip-flop over here on this line. Then same goes for the second flip-flop here in this yellow cable. Then for the third JK flip-flop, it's connected by the white cable. And with the brown cable, it's going towards the hub again. All of this is coming then from the output of this inverter. So let's look at it again. So we have our counter over here. Over here on the right, we have an AND gate, which has the output of our JK flip-flop D and the output from B. So if we see, this is B, and this cable is having the same signal. So this is B and this is D. Now everything is passing through this AND gate, and then coming out we have from the third pin connected to an inverter, which then takes the signal back to our clear hub, and then everything goes back to the JK flip-flops as explained before. So let's switch it up. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it should switch back. So we get 0, and then we get 1 and 2, and so on. So that's it for part 2.